Hello and welcome friend. In this new video we discuss about the inverse Laplace transform by convolution. The formula for convolution or inverse Laplace transform is L inverse of L inverse f1 of s into f2 of s equal to integration 0 to t f1 of x into f2 of t minus x into dx. This is the convolution formula for inverse Laplace transform. So let us see example how to find or how to apply this convolution theorem of inverse Laplace transforms to simplify the problems. So let us consider a simple example. L inverse of let us find s square divided by s square plus a square into s square plus b square. Here a is not equal to b. This is now going to solve this problem. Here you can see that we can write it as L inverse of s divided by s square plus a square into s divided by s square plus b square. And we have standard formula for this L inverse of s divided by s square plus a square equal to cos of at, whereas L inverse of s divided by s square plus b square equal to cos of bt. This is my first function. If we call it as a capital F1 of s and this is capital F2 of s, then corresponding function small f1 of t and this is small f2 of t. So that if we apply this L inverse of these two forms, s divided by s square plus a square into s divided by s square plus b square equal to integration 0 to t f1 of x cos of a x into f2 that is cos of b into t minus x into dx. Okay, now we suppose this is my c and this is my d, then cos of c plus d equal to cos of c into cos of c into let me see which formula is applicable. Here cos of c plus d into cos of c into cos of d minus sine of c into sine of d. Okay, and cos of c minus d equal to cos of cos of d plus sine of c into sine of d. Now if we add this, the sine term will get cancelled and we get cos of c into cos of d equal to here twice, we get twice cos of c, cos of c plus d plus cos of c minus d, or cos c plus cos d equal to 1 by 2, cos of c into cos of d equal to 1 by 2 into cos of c plus d plus cos of c minus d. Okay, so this is my c, you can see here this is c and this is d. So therefore we write that L inverse of this term, L inverse of s divided by s square plus a square into s divided by s square plus b square equal to integration 0 to t into 1 by 2 into cos of c, cos of here first term cos of c plus d, so ax plus bt minus bx, and this is cos into cos of c minus d into cos of ax minus bt minus minus plus bx into dx. Okay, here is a plus. Now we can easily integrate this. Again we know that this is 1 by 2. Integration of cos is sine of ax plus bt minus bx divided by coefficient of a and b, coefficient of x a minus b, plus sine of ax minus bt plus bx divided by a plus b, and it is between the limit 0 to t. So you can see that very easily we have converted, and this function becomes integrable. Now let us make some space so that we can integrate this integration, and here you can see that this is equal to here equal to this is 1 by 2 into, let us put above values, upper limit sine of at plus bt minus bt divided by a minus b minus sine of x equal to 0, so sine we get sine of bt divided by a minus b plus sine of at minus bt plus bt divided by a plus b minus sine of minus bt divided by a plus b. Okay, so this is we get. So here this is equal to, you can see that 1 by 2 into bt get here cancel, and we get sine minus sine of bt divided by a minus b plus, here bt get cancel, sine of at divided by a plus b, and minus plus sine of bt divided by a plus b. Okay, this is equal to 1 by 2 into sine of at minus sine of bt divided by a minus b plus this term denominator is same, so here we have sine of AT plus sine of BT divided by A plus B. Now let us take LCM. 1 by 2 into A plus B, A into sine AT minus A into sine BT plus B into sine AT minus B into sine BT plus A into sine AT plus A into sine BT minus A into sine AT B into sine AT and minus B into sine BT divided by A square divided by this A square minus B square. So what we have did, we have multiplied this numerator by A plus B term and this numerator by A minus B term. Now you can see that A sine AT, A sine BT, this minus A sine BT and plus A sine BT get cancel. Here B sine AT and B sine AT get cancel, and here we get, this is 1 by 2, this term A into sine AT and A into sine AT, here you can see that this term, so we get twice A sine AT and minus twice B sine BT divided by A square minus B square. Taking 2 common and cancelling with this, we get A sine AT minus B sine BT divided by A square minus B square. This is a answer of this problem. So it is quite lengthy, but if we go step by step and if we have a little bit knowledge of Laplace transforms and if we have a list of formulas, we can easily solve any type of Laplace problem. Now let us see one more problem to solve this, to get the idea clear. Let us find L inverse of 1 divided by S into S square plus A square. Now we write it as L inverse of 1 divided by S into 1 divided by S square plus A square. So you can see that this is my first function f1 of S, and this is my second function f2 of S. Then L inverse of first function 1 by S is equal to 1, as we call it is as f1 of t, and L inverse of 1 divided by S square plus A square, this is sine AT divided by A, standard formula, we call it as a f2 of t. Then this is equal to, apply this integration 0 to t, first function is 1, second function sine of A into t minus x divided by A into dx. Now 1 by A into integration of sine, that is minus cos of A into t minus x divided by minus A between the limit 0 to t. So you can see that this minus minus become plus, and we have 1 divided by a square. And let us put the value of t. So when we put here t x equal to t minus t, we get 0, and therefore very first term we have a 0, and minus cos of 80, x equal to 0, so cos of 80. And this is the answer of this problem. So friend, I hope you have enjoyed this, how to find the Laplace transform by convolution. Thank you for watching the video.